projects. In this video, we are going to explain the project, a secure and cost-efficient blockchain facilitated Internet of Things software update framework. Introduction. The primary goal of this project is to establish a robust and secure framework for updating Internet of Things devices across various domains. Internet of Things devices are used in various fields such as patient body temperature monitoring and traffic monitoring, and ensuring their software remains up to date is essential for their proper functioning and security. The project recognizes that traditional methods for updating Internet of Things devices have several vulnerabilities and shortcomings. These vulnerabilities include the risk of malicious software updates, weak payment systems, potential interruptions in the update process, breaches of confidentiality during data transmission, the possibility of receiving invalid software updates, and the threat of rollback attacks. These vulnerabilities can significantly impact the security and reliability of Internet of Things systems. To address these challenges, the project proposes the use of several key technologies such as blockchain, CPA-BE that is Cipher Policy Attribute Based Encryption, ECDSA that is Elliptic Curve Digital Signature Algorithm, and IPFS that is Interplanetary File System Storage. And blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And the project specifies the use of Ethereum's blockchain. Ethereum is known for more than just recording transactions. It also allows for the creation of smart contracts. These smart contracts are used to manage the storage and retrieval of Internet of Things software updates securely and efficiently. Objective of the project. So, as I mentioned earlier, the primary objective of the project is to create a framework that addresses the need for updating Internet of Things devices securely and efficiently. This includes ensuring that updates are reliable, tamper-proof, and can be distributed effectively to a large number of Internet of Things devices. The project aims to leverage blockchain technology to establish a system that is tamper-proof and decentralized. Blockchain's key features such as data immutability and decentralization will be used to maintain the integrity and security of software updates. CPA-BE will be employed for efficient encryption of software updates. It allows for the creation of a single key that can be used by multiple authorized Internet of Things devices, reducing computational overhead and storage requirements. ECDSA is incorporated to authenticate software updates and detect any alterations. It ensures that the received updates are from a legitimate source and have not been tampered with during transmission. The project aims to leverage IPFS to store encrypted software updates. This decentralized and cost-effective storage solution helps in distributing the software updates into blocks stored at different IPFS locations. This mitigates risks associated with centralized storage such as data loss or breaches. The project aims to create a smart contract using Solidity, a programming language for Ethereum's blockchain. This smart contract will facilitate the storage and retrieval of data within the blockchain. It ensures that data, including software updates, can be securely managed through the blockchain's capabilities. And the project is designed to be scalable, allowing it to be expanded to accommodate larger Internet of Things networks and applications. This scalability ensures that the framework remains viable for long-term use and can adapt to various deployment scenarios, making it versatile and flexible. Requirements needed to execute this project are hardware requirements, processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed few modules. The first module is Register. In this module, users can create an account. They need to provide basic information like a username and password. They can choose to register as either Internet of Things device manufacturer or Internet of Things device owner. The second module is Internet of Things manufacturer login. So manufacturers can log in using their registered credentials. Once logged in, they can access features specific to manufacturers. The third module is Upload Encrypted Blocks based software updates. So within this module, manufacturers can upload software updates. These updates are divided into blocks encrypted for security and then stored. The location of the stored updates is recorded in the blockchain. The next module is View Software Blocks. Here, manufacturers can view the details of software updates, including how they are divided into blocks and encrypted. This provides transparency and control over the software update process. The next module is View Payments. This module allows manufacturers to review payment records related to software updates. It helps in tracking financial transactions and ensuring that payments are accurate. The next module is Internet of Things Owner Login. Internet of Things device owners can log in using their credentials. Once logged in, they can access features designed for owners. The next module is Purchase Software Updates. In this module, Internet of Things device owners can browse and select software updates they want to install on their devices. They can make payments for these updates to ensure their devices have the latest software. The next module is View Payments. So this module allows owners to review payment records related to software updates. It helps in tracking financial transactions and ensuring that payments are accurate. So as actual Internet of Things devices are not available, the project employs a simulation-based Internet of Things application. The simulation involves Internet of Things devices connecting to the blockchain to download software updates. So the next module is Generate Internet of Things Network. Users can create simulated Internet of Things networks, specifying the number of Internet of Things devices and their configuration. This feature aids in testing the system's functionality. And the last module is Received Software Updates. In this module, Internet of Things devices receive and install the purchased software updates. This process ensures that devices are up to date with the latest software, enhancing their functionality and security. Blockchain integration. So blockchain technology was employed to enhance data security. Blockchain is like an unchangeable digital ledger that prevents unauthorized alterations to data. In this context, it ensures that the software updates for Internet of Things devices remain secure and immune to tampering. Unique hash codes associated with each data block within the blockchain were used to detect any unauthorized changes. These hash codes act like digital fingerprints, and if they don't match, it indicates that the data has been tampered with. This ensures the integrity of software updates and data. Smart contracts were integrated into the blockchain for the secure storage and retrieval of software updates. These contracts enforce the terms of data storage and access, enhancing security and reliability. Access control mechanisms based on blockchain were implemented to restrict data access to authorized users only. This means that only those who are permitted can view or modify the data, which significantly enhances data privacy and security. And blockchain technology was used to verify and record payments between Internet of Things device owners and manufacturers for software updates. This creates a transparent and reliable record of all transactions. The blockchain ledger ensures that all payments are legitimate and can be audited if needed. We have used Ganache in this project, so first we'll understand about it. So Ganache provides an interface that is easy to use and understand. It allows users to keep track of what's happening on the Ethereum blockchain without needing to be experts in blockchain technology. We can see information about accounts, that is the users, transactions, the accounts on the blockchain, and smart contracts, that is the programs that run on the blockchain. Ganache lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, that is gas, was used. This kind of information is valuable for studying and analyzing the behavior of the blockchain. Transactions are the actions that occur on the blockchain, like sending cryptocurrency from one account to another. Ganache displays the in-depth details of these transactions. We can see who sent the transaction, who received it, the amount involved, how much computing power, that is gas, was used, and whether the transaction went through successfully. This level of transparency is crucial for debugging and ensuring that transactions are accurate and error-free. Ganache allows us to keep tabs on the smart contracts. We can see where they have been deployed, what transaction was responsible for their deployment, and how much computing power was consumed during the process. This tracking is essential for confirming that smart contracts have been deployed correctly and are functioning as intended. Ganache is a secure place where developers can test their blockchain-based projects without any real financial risks. It is like a practice area where we can simulate, monitor, and debug blockchain activities. This is incredibly useful for ensuring the security and reliability of this project without having to interact with the real Ethereum network, which could be costly and risky. So Ganache acts as a safety net for testing and refining blockchain applications. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is contracts folder in which I have Solidity files. They handle data structures, functions, and events with modifiers for validation. This is static folder. It consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And this is Python main code file for IoT simulation. This is start IPFS batch file. So this batch file is used to start the IPFS, that is Interplanetary File System Server or daemon. So IPFS is a peer-to-peer network protocol that enables the creation of a decentralized and distributed file system. The batch file initiates the IPFS server, allowing users to share and access data on the IPFS network. It serves as the storage solution for encrypted software updates sent by the manufacturer. So I'm double-clicking on it. So we can see the IPFS server has been started. Now minimize this. This is run.bat file to start software update application, and this is run.bat file to start IoT simulation. So before that, we need to host the server. For that, open the Ganache. So the server has been hosted. Now minimize this. Now double click on run.bat file to start software update application. So the Flask framework will host the application locally at the default address, localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see IoT manufacturer login, IoT owner login, and register here links. So if we are new users, we have to register first. Click on register here link. First we'll register as manufacturer, fill in all these details. The username would be Ramesh. Give the password. Give the contact number. Give the email ID. Give the address. Select the user type from the drop down. I'm giving it as manufacturer. Now click on register button. So in the blue color text, we can see sign up process completed and record saved in blockchain. If we see the Ganesh, so here we can see the block created in which the user details which we have entered now will be stored. Minimize this. Now we'll register as owner. Click on register here link. Fill in all these details. The username would be Suresh. Give the password. Give the contact number. Give the email ID. Give the address. Select the user type from the drop down as owner. Now click on register button. So the sign up process is completed and record saved in blockchain. All these details will be saved to blockchain as a block. If we see in the Ganesh, we can see a block created in which these details will be stored. Minimize this. Now we'll log in as manufacturer. Click on IOT manufacturer login link. Give the previously mentioned credentials, username and password of manufacturer. Username is Ramesh. Give the correct password. Select the user type as manufacturer and click on login button. So we have logged in as manufacturer Ramesh, and here we can see upload encrypted blocks based software updates, view software blocks, view payments and logout links. Click on upload encrypted blocks based software updates link. So since we don't have actual software, we are using a file to represent software updates. Click on choose file button. So I'm uploading this file and click on open. So the file has been uploaded. Now click on submit button. So here we are dividing the same file into multiple blocks, encrypting them and storing them in IPFS. The addresses of these blocks are stored in the blockchain, and here we are showing details such as file name, block names, encrypted content and verification codes. Now click on view software blocks link. So here we can view blocks of all files. We can see the manufacturer name, software file name, uploaded date. So these are the blocks of the same file, and these are the verification hash codes of the blocks. Now click on view payments link. So here manufacturers can view all received payments from owners. So there are no payments received yet. Now click on logout. Now we'll log in as owner. Click on IoT owner login link. Give the credentials, username and password of owner. Username is Suresh. Give the correct password. Select the user type as owner and click on login button. So we have logged in as owner Suresh, and here we can see purchase software updates, view payments and logout links. Now click on purchase software updates link to view all available updates and purchase desired updates. So here we can view list of available updates. We can see the manufacturer name, software updates, file name, uploaded date and a click here link. By clicking on it, we can purchase the update. So I'm clicking on click here link of manufacturer name Ramesh. So here we have to enter these details. The manufacturer name is Ramesh, software name is Flow, and payment amount would be 1000. And we have to select the IoT ID. I'm giving it as IoT1. Now click on submit button. So in the red color text, we can see payment successfully done for IoT1. So here we are purchasing software update for IoT1. So in simulation output, we can see IoT1 will be receiving and updating updates. Now click on view payments link. So here owner can see list of software updates purchased and the amount paid. Now click on Logout. Now double click on Run IoT simulation.bat file import folder. So instead of executing the project through command line interface, we have created these Windows BAT files. This graphical user interface will be open. With this, we're interacting with the program. We have used Tkinter library to create this graphical user interface. Now enter the number of IoTs to be created. I'm giving it as 20 and IoT ID is 1. Now click on Generate IoT Network button. So here all red color circles are IoT nodes and are placed at different locations. As we have given number of IoTs as 20 IoTs are created here. Now click on Received Software Updates button to download and update software only for those IoTs purchased by owner. So here we can see IoT devices for which the owner has purchased updates are indicated by a change in color to green, signifying that they are in the process of receiving updates. And we can see the same in text area also. So IoT 1 and IoT 0 have purchased the software updates. Now in the software update application, login as manufacturer again, click on IoT manufacturer login link. Give the credentials, username and password of manufacturer. Select the user type as manufacturer and click on login button. So we have logged in as manufacturer Ramesh. Now click on view payments link. So here manufacturer can view list of payments received for software update purchase. We can see the owner name who has purchased the software and we can see the manufacturer name, the payment received for IoT ID, that is IoT 1, the amount, payment date and purchase software name. Now click on Logout. So all these transaction details will be saved in the blockchain in the form of blocks and we can see the blocks created in the Ganache. Now click on the block. So here we can see the block hash code and the transaction hash. Click on transaction hash. So here we can see sender address, to contract address, gas used, gas price, gas limit and the transaction data also. Now minimize this. The conclusion here is the project effectively mitigated vulnerabilities in traditional IoT software updates, ensuring improved security and reliability. This was achieved through the use of blockchain, CPA-BE and ECDSA technologies. Blockchain technology played a pivotal role by providing tamper-proof data security, guaranteeing software update integrity, and facilitating transparent payment handling. This ensured trust and reliability in transactions. The incorporation of CPA-BE reduced computational overhead in key generation, simplifying access control. This efficiency improved overall system performance. Utilizing IPFS storage not only provided cost-effective but also enhanced security by distributing software updates into blocks at different IPFS locations. This innovative approach mitigated vulnerabilities associated with centralized storage. The project effectively integrated Ganache, enhancing the development and testing of IoT software updates. It provided a user-friendly interface for monitoring blockchain activities, contributing to project security and reliability. And the project's scalable design, validated through simulation, allows it to adapt to larger IoT networks and diverse applications. It demonstrated successful software update reception and application, affirming its functionality and effectiveness.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.